Duncan said, I don't have to go faster, but I will. This talk is based on a talk I gave. It's based on a long report that I spent a long time writing and thinking about. I basically gave myself 2 years to spend like something like half of my research time thinking about how AI technology could play into existential risk. And there's a lot of existing stories for how that's going to play out. And I think there's a lot more stories that we haven't thought of for how it could play out. And so part of what excites me about this finding the right abstractions theme is that it helps us, it could be helpful to, just identifying more narratives for how things go wrong that we can then avoid. So let's see, it looks like my slides are only like embedded in the browser. And if I use, I think I'm going to have to redo the screen share. 1 second. It looks that's working now. Okay, and it's still fine for you guys, right? Like there's like a browser tab at the top, but otherwise it's fine. Okay, I can see it. Oh, great, great. Here we go. That should work. First thing I'm going to say is grab slide numbers. So I have numbers on all my slides. For some reason, not everyone always numbers all their slides all the time, and that's insane. Instead, I number my slides, which is sane, and you can just write down a slide number and tell me to go back to the slide if you ever have a question about it. Okay. So here's my case for why AI X risk is real. I think people have different amounts of fear about AI killing all humans. And my goal here is not to appeal to fear. It's to appeal to reason. And I think it's very reasonable to assign a very high probability to humanity becoming extinct through the advent of AI technology, whether it's a single decision-making entity that brings about the extinction or whether it's a gradual replacement of the human biological strategy by other strategies that are faster and more competitive than humans. I think it's quite likely. And the argument I want to make for it is this. I'm going to go a little bit faster than I otherwise would. But just imagine, the state of the Earth. It's this massive dimensional variable. Time is going to pass. And there's just so many states the world could end up in. Most of those states are not states where there's even a single human-shaped body among the configuration of atoms on the surface of the Earth. So if you just do a dimension count, it's just insane. It's insanely unlikely for humans to show up in a random configuration of atoms. Of course, we don't have a random configuration. We have an evolved configuration. But that said, if we hand control of the Earth to a random control process, that control process will steer the Earth into a state that doesn't have humans in it. So the default thing we should expect if we hand control of the Earth over to processes that are not human, by default, we should expect that those processes will change in such a way that humans don't exist, in the way that humans change the Earth in a way that, damages habitats of like lots of other animals. So that's like not a particular story. It's not a statement about like a super intelligent mind in a box is going to break out and take over the world. It's not a story about, automation is going to replace everyone's jobs until they have no money and starve. It's any of these pathways. Human extinction is a disjunctive condition, not a conjunctive condition. And the reason is that human existence is a conjunctive condition. You need a conjunction of a massive number of predicates to hold in order for a human to be alive. So by default, we should expect humans to not be alive unless we do work to keep them there. So the way people started thinking about this with AI is in terms of a few different abstractions, which I'm going to quickly lay out here. One of them is an assistance relationship between an AI and a human. So the AI should be designed to assist a human user or a human institution that it serves. And you can think about that in terms of breaking up. You can break that problem up into a few different subproblems. If you imagine the human has some kind of intention or goal or utility function or preference, any of that can go in this thought balloon here. And if you imagine making machines that operate in such a way that it makes sense to attribute to them an intention. The problem of intent alignment is ensuring that an AI system's intentions are aligned with the human's intention. So it's kind of trying to help you with what you're trying to do. There's another concept called impact alignment, which is making sure not just that the intentions of the robot or the machine or intelligence are aligned with you, but also that its actions, the effects that it has on the world, including unintended effects, the entire impact of the AI technology that you're using or that the institution is using should be aligned with what you intended for it to do. So that's called impact alignment, but some people call it just assistance. Like if it's successfully assisting you, it's helping with your intentions. So you could just view this as a refinement or restatement of the assistance relationship. And there's a few other abstractions here that are pretty important that go the other that you can sort of one is this interpretability abstraction that goes the other way. It's saying can the human understand the intentions of the AI system or technology once it's running? And that helps with, debugging. If it's doing something wrong, you might say, wait, were you trying to do that? And it might say yes, or you might read its mind and observe, yes, it is trying to do that. And you have to change its intentions. Whereas if it's not trying to do it, you might need to just tell it more about how the world works so it doesn't mess up. And that brings us to safety and robustness. So there's this whole massively, rapidly growing area of AI and machine learning that happens under the header of either safety or robustness, or sometimes generalization, where the goal is to make sure that the AI can do what it's trying to do. And you can imagine if you have a solution to intent alignment and you have a solution to safety and robustness, you can compose those and say, well, the AI's intentions are aligned with me, and it's able to act on its intentions correctly and safely. So that means its actions are going, and the impact that it has are going to be aligned with me. So those are some different areas, and there's different people working under each of these areas. And I'm going to rapidly flash through. I'm not going to go into. I don't really have time to go into all the different papers. But you have at CHI, where I work, the Center for Human Compatible AI, this cooperative inverse reinforcement learning framing, where you kind of think of there being a game between the AI and the human, and the AI has to figure out what the human wants over time and learn how to help. And then there's a teaching relationship that then emerges, where the human is trying to teach the AI what the human wants. And even before this particular framework come up, another one of our PIs at CHI, Anka Dragon, it was working on formalizing what does it really mean to help somebody remotely operate a robot. And if you can write down really good expressions of what it means to help someone remotely operate a robot, then you can help them remotely operate the robot better. And so that's I would say all under the assistance or impact alignment framing. And then here's some work that also I think falls under that framing, where this is a take on how to basically scale together, not just scalable in terms of the total amount of computation, but also scalable in terms of the number of agents, to get a solution together for how to get lots of AI systems and lots of humans working well together. And then this DeepRL from Human Preferences is a really, if you haven't seen this, I totally recommend checking it out. It's a little robotic sprite that was trained to, this video here, there's other things in the paper, but this video is of a little robotic sprite that was trained to do a backflip with just yes or no inputs from a human. Like it flounders around and a human says, yeah, that was closer to being a backflip, or that was not a backflip at all, don't do that. And eventually it learns to do a backflip, and it does this, as you can see, it has a number of different joints. And it learns to do the backflip with about 5,000 bits of input. So just 5,000 yes or no inputs from humans that didn't require the humans to be engineers. It didn't require the humans to read or write anything. They just said, yeah, that was pretty good. So you could imagine getting a lot of economic activity by just farming out approval, the task of approving of good AI behavior to lots and lots of people, and having them say, yeah, that was good, no, that wasn't. And then the AI gradually figures out how to do good stuff. And that I would consider impact alignment, because we've seen the robot actually learns to do a backflip. But Paul also thinks a lot about, Paul Cristiano thinks a lot about how to align the intent of the machine. And there's other thinking on that from Rohan and Anka. So here's some people who think about interpretability. Screenshot that if you're interested. Here's some people who think about safety and robustness. You can screenshot that if you're interested. I can also just share my slides, but the upshot here is that there are people thinking about the global impact of AI and the possibility that it could destroy the world and humanity. And they're all coming at it from these different angles. You know, they're not all taking the same perspective on it. And you might then ask, okay, what's next? What perspectives haven't been taken? And I think, you know, David talked a lot about interaction and how basically the domain of his utility function, or the possibility space of his preferences, was shaped through a lot of interaction. And I think this space of people is not thinking that much about interaction yet. So that excites me in terms of what could come out of this workshop. You could imagine over time, at first you have humans interacting with each other and using machines to help them, like calculators. But my calculator doesn't interact with your calculator. It interacts with me. But now we have social media, and my social media platform totally interacts with yours. My content recommender interacts with your content recommender possibly by being the same content recommender. And you can imagine over time, more and more of the interaction being intermediated by AI systems, such that it stops feeling like the AI is helping me interact with you, and instead I'm delegating the interaction to the AI. And if we do that, you know, if the capabilities increase, we might imagine delegating really complex interactions to AI systems, like running a company. And if we do that, here's another one: government agencies. You could imagine delegation of running the NSA or running the Department of Public Health to an AI system. That's quite advanced compared to what we can do now. But if that happens, you could imagine delegating away so much activity that those activities by accident destroy humanity. And how could that happen? Well, I don't want to specify. I don't want to tell one story. If I tell one story, then there will be a caricature of that story about how that story is not realistic. And no particular story is going to be realistic. The point is, there's just so many ways we cannot exist. All we need is for one of those ways to obtain, and then we don't exist. So that said, you can categorize them a little bit. You could think, do the sources of agency that lead to human destruction, are they mostly in conflict with each other? Are they mostly cooperating with each other? Or does the conflict cooperation taxonomy not work? In which case you might say there's a more complex relationship or process among them. If agents are conflicting, you could imagine a war that kills everybody. You could imagine countries delegating military operations to AI systems. Like, this is an active area of research. The DoD is trying to build general advisors, like advisors to military generals that run on AI. A natural approach to that is to try and make complementary tech that would engender cooperation rather than conflict. So we see people like Alan Dafoe at Oxford working on, trying to support more thinking in this area, especially among people who care about existential risk. And he has this paper, if you haven't read it, Open Problem with Cooperative AI. It's interesting. It's not written with the DeepMind safety team. It's written with the DeepMind multi-agent team. And coming back to transparency, which I had mentioned was a good debugging tool, it can also help with cooperation, because if your AI is transparent to me and my AI is transparent to you, we maybe can trust each other better and be more likely to cooperate. And so interpretability work, I would say, flows into mutual transparency and cooperation as an outcome. So it's another reason why I really like interpretability as a concept. We could define interpretability really well as a result of this workshop. That'd be amazing. And I think fairness is another concept that lots of people think about, but not as much in the X-risk space. And I think that's a mistake. I think it's unfair to create a technology that kills everybody because everyone else didn't help you create it, and they didn't really get a say in what happened. So there's a lot of ways in which if tech development were more fair, by definition, it wouldn't allow big risks to be taken with everyone else's lives. So you can imagine ways of operationalizing fairness that keeps the world on more of an even keel and keeps everybody involved in the decision of how big of a risk we should be taking. Then if we do really well on the cooperation axis, maybe AI cooperates so well with other AI technologies that the humans are sort of left out in the dust. You could imagine that you would describe the economy as colluding against humanity, but it really might not be as nefarious as collusion. We don't collude against other species. We just kind of build our housing complexes and cities and highways where we want them. And here's an example of this is the minimum viable self-contained economy that I could think of. Pardon me, I'm not going to answer that uncharacteristically of me. I usually always answer the phone, but I guess I'll make an exception for now. Yeah, you can imagine delegating out lots of these tasks, and then if we succeed in getting machines and AI systems to cooperate on these tasks, you can imagine an entirely self-contained economy developing over time through competitive pressures to make each of these economic activities faster and more automated, more efficient, until the whole process can run on its own. And now humans are not in the loop, so if it starts having negative side effects, we have a lot less leverage to stop those side effects because the whole economy is just running without us. And again, what particular side effect is going to get us? Don't care. There's so many of them, it doesn't matter for my argument. And then, of course, there are more complex processes like, David mentioned vibing, Can you vibe in a debate with somebody? I think so. Is that cooperative? Well, sort of. You're like cooperating on the task of like staying in the conversation. And you're maybe cooperating on the task of understanding each other if you're doing well, but you're not necessarily cooperating on which belief to have next collectively. Like I'm bidding for us to have a particular belief next, and you're bidding for a different belief. Is that cooperation or is that competition? It's a bit of both. I think getting a better handle on a better, more nuanced taxonomy of how relationships between two agents could be characterized with more nuance than conflict or cooperation, I think is probably key to actually understanding and not being overwhelmed by the complexity of the AI transition, as David would describe it. And in promoting these many different angles, I'm hoping to just have lots more AI researchers existentially conscious. By that, I mean, I have this X-conscious term that I use in my head, which is this person thinking about whether humanity is going to be preserved or not? A lot of people don't think about that every day. I think about it every day. Is humanity going to exist in 20 years or in 100 years or 1,000 years? I'm not going to give you my population growth model for increasing the number of X-conscious people, but I think it's good to increase the number of X-conscious people. I think it's a good strategy, as David would say. And I don't think that these abstractions here, I'm going to try and race through them, but these abstractions here, they're good. They're being developed. People are thinking about them. So a lot of people, I shouldn't say a lot, a number of people are thinking about each of these abstractions from an existential safety perspective. That is to say, the perspective of preserving the existence of human civilization. But I don't think they're adequate still. I think we need better fleshed out mathematized concepts that cut across the boundaries of agents, such as, like David pointed, this possibility space underlying our preferences. That possibility space was developed through discourse and interaction across many humans. So there wasn't a single agent who discovered the possibility space for your preference. And there's a question of, I love this question. Do we cultivate potatoes or do potatoes cultivate us? Who's in charge, there might be no real definition of that, or the definition might not be binary, or it might not be a scalar. And I'm also interested in what is life or what is health. to the extent that humans are alive and healthy and society is alive and healthy, I want us to understand how that works and keep it going. And unlike David, I do want humans to control AI. And if I was going to make the case in his language, I would say cultivating strategies you can't control is a bad strategy for continuing to exist, that is. And the cultivation process that he alludes to, evolution, is one in which strategies emerge, and those which manage to exist well continue to exist, and the ones who don't. I intend to be one that manages to exist, because I think that's in the spirit of the existence game that we're playing. And I hope I can convince David and some more of you to play to win in the existence game by understanding what existence means for us and how to preserve it. Until there's enough people who have this existential consciousness property that we can count on, I'm missing a circle. There it is. So we can count on whoever the most pivotal AI researchers are in the world. There's a sampling among them of people who are existentially conscious and who are going to be careful with preserving human existence through the transition to increasingly capable AI technology. All right, that's my spiel. Thank you.